Good morning, my dear students of second secondary. Today's lesson is called Meeting the Lines of Action of Three Forces which are in equilibrium. This lesson is the last lesson of statics in math applications. This lesson is given only for scientific section. Let's start. Meeting lines of action of three equilibrium forces. The first example, complete the following by drawing the third force to make the two shown forces are in equilibrium with it. In figure 1, there is a metallic rod named AB, labeled as AB. It is drawn two forces, its weight and the first tension force. Take care, the rod AB rests on a vertical wall. Then there is a reaction force. There is a reaction force from the vertical wall against the metallic rod. Take care. The lines of action of the three forces should be concurrent. The three lines of action should meet at one point. Therefore, on drawing the third force should pass through the point of intersection of the weight and the tension force. I'll draw the reaction force here. I'll draw the reaction force to pass through this point, which is the point of concurrency of the weight and the tension force line of action. In figure 2, the metallic rod is labeled as AB. It is drawn the line of action of the weight and the reaction force. It is required to draw the third force to be this system in equilibrium, to get the system in equilibrium. Then I'll draw the reaction force. I'll draw a tension force, from the point A, and this tension force should pass through the point of intersection of the weight and the reaction force. In figure 3, the metallic rod AB rests on a vertical wall and a horizontal plane, a horizontal floor. Then you should draw the third reaction force passing through the point of concurrency of the weight and the first reaction force. These two forces meet at this point. Therefore, the reaction force is the second reaction force. This is R2. Another example. A solid uniform sphere of weight 15 gram weight and radius length 10 centimeter is in equilibrium by string of length 10 centimeters attached to a point of its surface, and the other end of the string is fixed at a point in the vertical smooth plane above the tangency point. Complete the following. It is required to find the reaction force and the tension force. Given the weight of this metallic sphere equals 15. This metallic sphere rests on a vertical wall, AB. Then it is given a right-angled triangle, ABC, where measure of angle B equals 90 degrees. The weight of this sphere equals 15 gram weight, and the radius length of the sphere equals 10 here. This is the radius of the sphere, which equals 10 centimeters. Also, this is a radius equals 10. And it is given that the length of this string also equals 10 centimeter here, 10 centimeter. Take care, the hypotenuse of the right angled triangle AC equals 10 plus 10 equals 20 centimeters. Also BC equals 10. Then I can calculate AB using Pythagoras theorem, which equals square root of 20 power 2 minus 10 power 2 equals 10 root 3 equals 10 root 3. Here AB equals 10 root 3. I can use the triangle of forces rule, where the weight 15 can be represented by the line segment AB. Therefore 15 over 10 root 3, and the tension force over 20 centimeter, and the reaction force over 10 centimeter. Here the reaction equals 10 times 15 over 10 root 3. 10, the reaction equals 10 times 15 over 10 root 3. Here the reaction equals 5 root 3. And the tension force 20 multiplied by 15 over 10 root 3 equals 10 root 3 gram weight. I'm sorry. The tension force, I write cross multiplication elements, 20 multiplied by 15 over 10 root 3. Another problem. AB is a uniform rod of length 40 centimeters and of weight 30 Newton. Is attached to a hinge at A and it is kept in rest horizontally. By a string. Its two ends are fixed at B and C, where C lies on the wall above A and AC equals 40 centimeters. Then, or it is required to find the reaction force and the tension force. Here, the uniform rod AB, its weight acts at the midpoint of it. Take care. In any uniform rod, the weight acts at the midpoint. In the opposite figure, the length of AC equals 40 and AB equals 40. The weight bisects AB to be 20 centimeter and 20 centimeters. I can use the triangle of forces rule, where measure of angle A, here measure of angle A equals 90 degree. The weight acts vertically downward and the weight bisects AB. This is the midpoint of AB. And the direction of the weight is parallel to AC. Therefore, this point is the midpoint of BC. Therefore, the line of action of the reaction force is a median in the right angled triangle. Median in the triangle. And the length of the median in the right angled triangle equal half the length of the hypotenuse BC. Here, BC equals square root 20 power 2 plus 40 power 2 plus 40 power 2. Therefore, BC equals 40 root 2. Then the length of the median equals half BC equals 20 root 2. Also, this is the midpoint of BC. Therefore, this line segment equals 20 root 2 and here 20 root 2. Then, or I will take this triangle as a triangle of forces, where the median is the line of action of the reaction force. This line segment is the line of action of the tension force, and the CA represents the weight. Therefore, the weight equals 30 over the length of CA, which equals 40 centimeter, and the tension force over 20 root 2, and the reaction force over 20 root 2. Find R, where R equals 20 root 2 multiplied by 30 over 40, which equals 15 root 2. This is the value of the reaction force. Also, the tension force equals 20 root 2 multiplied by 30 over 40 equals 15 root 2. Another example, a sphere rests on two parallel rods located in the same horizontal plane. The distance between them equals the radius length of the sphere. Find the pressure on each rod if the weight of the sphere is 10 Newton. You should firstly try to draw this figure. Here, a sphere rests on two parallel rods. Where the distance between these two rods equals the radius of the sphere. I'll draw the first reaction force and the second reaction force. Take care, these two forces should be concurrent and all the forces should pass through the center of the sphere. Then I'll draw this triangle. Take care, this is R, also this is R. Also the distance between the two parallel rods equals R. Given that the weight equals 10 Newton, it is required to find the first pressure force, which equals the reaction force, and the second pressure force. Take care, if the three sides of this triangle are equal, then this triangle is an equilateral triangle. This triangle is an equilateral triangle. Where the measure of each angle equals 60 degree, and here the direction of the weight is perpendicular on the base. Therefore, the line of action of the weight bisects this angle bisects this angle 30 degree to be 30 degree and 30 degree. And here the direction of the line of action of the weight is perpendicular to the base. Take care. In this figure, this angle equals 60 degree. Also, this angle equals 150 degree, which equals 120 plus 30, and this angle equals 150 degree also. Therefore, 10 over sine 60 equals P1 over sine 150 equals P2 over sine 150. Then P1 equals 10 sine 150 over sine 60. Also P2 equals 10 sine 150 over sine 60. Here P1 and P2 are two equal forces and their magnitude equals 10 multiplied by sine 150 over sine 60 equals 10 root 3 over 3. Thank you and good luck.